Hello viewers, this is Mithul here. In this module we are going to cover the module 3.7, the other data types 1, which will be the first is geography, then geometry, hierarchy ID, JSON, and then vector. Okay, so let's get started. Okay, now 3.7 other data types, in which like we are going through geography, the spatial data type. What is geography data type? Why we use it, right? So it represents the data in the round earth coordinate system. Now SQL Server geography data type stores the round earth data such as GPS, uh, latitude and longitude coordinates. Okay, so it can be used in a persisted or non-persisted computed columns as well. So let's just see like how it can be used. Now you need to remember these two terms for that, like OGC means Open Geospatial Consortium, and then WKT is well-known text. Okay, now for both of this definition, the method definition, you will be using this OGC and WKT term. Okay, now what is STA's text method and what is STGeom from text method? So both of them are basically geography data type related method. It returns the OGC WKT means well-known text representation of the geographic instance. Okay. Now it won't contain any Z elevation or M measure values carried by the instance. So remember, in this STAS text method, it would not contain any Z elevation or M measure values carried by the instance. Whereas in the second method, which is STGeom from text, it is using any Z elevation and M measure values carried by the instance. Okay, so there is a slight difference with or without, only that is the difference in these two. Now let's just see the usage. Okay, so first of all we'll take the example of the non-persisted computed column, and then we will take the example of persisted. Okay, so first of all we'll go with the non-persisted one. Let's see, first of all we use the our regular, like the learning DB, just to use it. So we'll just run it so that we see here it appears that we are now using the learning DB. Now this is just to disable the counting in the result set. Okay, that you will learn afterwards. So drop table statement I am using just to make sure, like if there is any existing table, we need to remove it before we create it. Okay, so then we can create it. All these three columns are different columns. The first one is the identity column, starts with 1, increments by 1. Coordinate column is for the geography data type, and calculated column is how do we create it? It is created as with as keyword. You will put in the same column name what is there in the geography column. Okay, the same name column that you will put in here, then dot STAS text method. What this method would do is the geography content, or say like the geography, how it is saved in the database, it will convert that string into the text format so that you can understand, or human readable format. It will convert in the human readable format, this calculated column. Okay, so and basically this can be called as a non-persisted computed column. Now let's just insert into this table. What we will insert? We will insert only the coordinate column. We will not insert this calculated column. Now you may ask why we would not insert this column, because we are just passing this value, and the same value is being utilized to display or to insert the value for calculated column. You see, like the coordinate column is the same column we are using here. So ideally we need not to pass any alternate value, or say like additional value. Instead we'll just be passing only one value, which will be like coordinate column, and then it will be used as a base to display or to store the value for calculated column. okay, using this method. For that reason we are passing only one value, and for that one value how can we pass the value to it? Very interesting, which is like a geography, this is the keyword, then double colon, okay, 2 times double colon, then stgeom from text, okay, the same method what I explained here, that is the text that we would be using, or the method that we would be using, and within that method what we will pass? We will pass the polygon method, or say like a function. So what that function would retrieve within that is, it will just fetch the coordinates, particular coordinates to design the polygon in the spatial or say like in the geographical way, just to form the polygon object, right, like an instance. to, to, to draw that kind of an instance, we are passing the parameters, or say like the values for that, where and how it will be formed, that polygon, okay. And now this is like 4326 is what? 4326 is okay, it's just like a reference ID, okay, just for your information, it's a reference ID that we use, okay. So yeah, so then we will, yeah, here it is mentioned spatial reference ID, so you can understand from that, right? So what we are doing here, passing the two records, or say like a two values. The first one is the geography stgeom from text, and then there is another value which is for the line string. So here we are forming two objects. One is the line, is what we are drawing, and then we are drawing the polygon, okay, using these coordinates. So these all are the input parameters. This is like a starting point, and this is like an ending point. Now for the starting point and ending point, there will be longitude and latitude values, right, for both of them. So respectively I have mentioned it here, say like 122 minus 122.360 is the first value in the argument here. That will be the starting point for the long, and will be the longitude value, and then 47.656 is the latitude value. Likewise the ending point, the starting value will be used for the longitude, and then the second value will be used for the latitude value, okay. So that is how the line string function will be drawing the line. And then the second one is the spatial reference ID. This is like a spatial reference ID that we would be using, okay. Now we need to have that, then only we can pass it to it, okay. So just for example I have taken it, so just try to understand basically that way. Now after we will insert these records into the spatial, the TVL spatial table, what we will be doing is, like, we will try to see the two geographic instance, means like we will try to bring the intersection value out of these two objects, right? So how can we bring that up is, first of all we will declare three variables, like variable geography ID 1, which is geography data type, variable geography ID 2, which is geography, and then the resulting variable, whatever the result of the intersection comes from this two variable, that will be storing into the third variable. Now based on the ID we will be fetching the first value into that, and based on the ID 2 we will be fetching the second value for that. And then out of this two variable we will pass in this value, like a variable geography ID 1 dot st intersection. This is another method. This method returns the points where the two previously inserted geography instances intersect, means these two values, the value 1 and the value 2, wherever they are intersecting with each other, right, at that point only, or those points only, it will cover up in this results, okay. So that it will fetch it into that, and then after it fetches that, we will try to display the coordinates to that using the stas text method, okay. Now what we should do is, like, let us just run this much part so you will understand, okay. So starting from the drop statement, we'll run this. So we dropped the table and then we created the table. Now we are trying to insert the values. Okay, it has got inserted into this table, and now we will be passing in this table what is the value to that. Let's see to it. Okay, let's just run this much now, because we just inserted the record now, so we can see to the values, because the table, the TBL spatial is having data now. So we'll be trying to display those values using this intersection value, right? In case if we want to see to the value from the table, what was the value that was inserted into that table, that we can see using this select command, select statement. Okay, so we'll display this select values. So we inserted two of these values. Now you may see easily that how the geographic value gets saved into the database, right? This is how it gets saved in the database. Okay, like this column. This is the second column, right? What we saved in coordinate column. So this is the coordinate column where actually it is getting saved in the form of binary, we can say. Okay, so it is saved here in this column, but when we actually wanted to display this column, right, then it has converted it into the text form. How we inserted them into the table, that is the value that you get to see using this function stas text. That function itself will convert this value, means this value, back to that original value. Okay, so this is the original value that we passed in, and this is the after converted into, or after it is saved into the geography data type using the data type. So the second record was line string, right? So the line string also you can see the arguments, what was the value that we passed in, the same value that we can see with the calculated column, and in the calculated column we have used the stas text method, so that we are seeing the clear text, and this is like a binary converted or saved value. Okay, so now as we see values are there in this table, now we can check the intersection between these two values, means like the intersection of two values, like we will be subtracting the value 1 from the value 2. Yeah, so here we can see that what is the intersection value. Okay, so this is the value that we get after we convert both of these record into that. Okay, I think we should be just using this first value. And that too, we do not need the value to be shown. So we just say like a distinct instead of that. Okay, let's just say distinct for that sake, and try to display the value. Okay, so now it will just display the single value. Okay, now the intersection value is displayed as if the point, let's say like if it was not there, what was the actual value for that, right? Let's see both these values together. You see there is no difference. For that reason I have converted it into the distinct here. Okay, so if you want to just get retrieve only the single row, we will use the distinct keyword and then run this merge part, and this is where you will see the distinct value for that. Now if you just display all this value along with the actual column as well, right, the calculated column as well, right, so we may get this spatial value also. I wanted to show you actually that spatial value, that the object how it is formed, that you can see in the result of this table. Select star from spatial. Let's see. So here I wanted to show you this object. So the coordinate wise, whatever value that you saved, right, like the value what you have passed is what you are finding in here. The polygon is formed and the intersection value is highlighted in this region according to that, right? So you can see like 47.653 one coordinate there, right? Then 649 at which the other one is there, then 658 at which some other one is there, then again. So likewise it is forming the polygon, and likewise the line string also gets formed, which is like 47.656 from where the line is formed, and then minus value from that 122.343 from there. So that's how basically the spatial results come based on the query that you may use and run it. Okay, query. Now this was the way for the non-static, or say like a non-persisted computed column. Okay, now we want to see the persisted column, the calculated column, persisted column. Like, so what is the difference in the persisted computed column is it returns the geographic object that represents the union of all points whose distance from a geography instance is less than or equal to a specified value. So means we are passing in a particular or defined value for that, which will be used to form the union of all points. Okay, that is why it is called a persisted value, where the values are defined in there, and in the case of non-persisted it is not defined there. Okay, so that's the only difference in the the construct of these two. Otherwise the data type can be used the same way. There is no difference. Like here it is LOC underscore geography. The same way the same variable will be passed for the calculated column, and then use the stbuffer10 method, pass the argument to it, like how many characters you want to save or how many points that you want to save to that. So that is what you will be saving into that, and it will give you the output for that. Okay, so this is all about geography data type. Let's just move on to the geometry data type. This is again the similar kind of data type which is used for the spatial purpose. Okay, now the declaration and the usage wise almost the same. The methods you may see, like to display in the clear text you may use the same method as we used in the geography. The same way you may for passing in the value also, you can use the geometry from text method. Okay, so let's just run this function, the statement, and then we display the value from there using this select statement. Geometry data. Okay, let's just run this much. Okay, we created the table, then we do the insert. Okay, now we run this select statement, see the values. Okay, now see that there are two records that we inserted using this thing, the two different set of values that we have passed to form the polygon. Okay, now how that polygon is formed in the spatial result is how this is how it is formed, right? Like a geometric, like the same way geography and the geometry, both different sort of but still the same spatial result. This is how it will be displayed. So this is like an intersection part that you may say, right? This is the ID2 and this is for the ID1, means like this is for the 0 0 this polygon and this is for the second one. So both of them are used, like ID1 will be used for the first record and ID2 will be used for the second record. So ID2 is a second record, right? So both of these has as intersection value, which is this, that is what is displayed. Okay, otherwise rest of the things are same, no difference in there. You can say that area, if you want to say, let's say you want to display, right? How will you understand? This is how you may understand that intersection area of that. And here also we may use the same statement like listing and yeah. Okay, now as we see this value, okay, now we see that the intersection value, what is the intersection value? 1, and it is between 1 and 2, right? So it is between 1 and 2 only, right? Here that the starting point and this is the ending point, like that the polygon forms. So different points are there, like the 4 angles that we want to design, right? For that, so 1 2 3 and 4, so 4 points are formed using this 4 type of argument or the 4 type of values, or say argument values. So the first, second, third and fourth, and one this is like the fourth, I think. Yeah. Now we will move on to the third type of data type, which is the hierarchy ID. Now how is hierarchy ID used? Hierarchy ID is the data type which is a variable length and of system data type. Okay, now hierarchy ID is to be represented to position in a hierarchy way. The column of the type hierarchy ID doesn't automatically represent a tree. It is up to the application to generate and assign the hierarchy values in such a way that the desired relationship between the rows is reflected in the values. Now a value of hierarchy ID data type represents a position in a tree hierarchy. Now when we say like hierarchy, you know that by the term you understood like what is hierarchy now. So how hierarchy is formed? Hierarchy will always have a root to it, correct? Then the branches of it and then the nested level will be there. Likewise, so the root of the hierarchy is designed or created in this column is using the forward slash, or say like a root of the hierarchy tree, like a single slash. That is what we will use, like the forward slash as a single slash. That will be the considered as a root of the hierarchy tree. Then the four levels underneath the root. Now the second level after the root, each label is encoded as a sequence of integers separated by a dot, like in here. Like you see that it is separated by a dot, right? Don't consider it like 0.2 point something like that. It's considered as if like a separate values to it. Okay, so that's how it is. It's separated by the dots, and the comparison between children is performed by comparing the integer sequences separated by dots in a dictionary order. comparison between children is performed. Means when you have to compare both the dictionaries, suppose if there are two hierarchy ID columns that you need to compare, so in that way, when you will be comparing those kind of values, at that time you may have to compare it using the separate dots given between those values, right? Now each label is followed by a slash. As you see, each label is separated by a slash. So here you see the root value. Then in this example you see like that this is the root and this is the first label. Now here in this case again this is the root and this is the first label, right? Likewise here this is the root, the first label and then the second label, right? That is how it is created. So for each label we have to separate them by a slash. Clear? Now the rules, how this hierarchy is following some rules, right? So nodes can be inserted in any location. Means if a node you want to insert, say like here there is one value we have written, right? We want to insert one more value to it. How we can add it? Like this point, we can put a point over here and then put in the other value, right? That way you can put in another value to that. Okay. Nodes inserted before 0 have the logical representation as a negative number. In this case, maybe just for an example, if you want to say, like for example, a node that comes before 1 slash 1 can be represented as 1 minus 1. Means like if you want to say like in example, okay, if you want to say like previous step, if you want to mention it like that, right? So in that case, this is like the current state, current level. Okay, now if we want to go to the prior level, then the negative numbering will tell us that this is the level before the current value or the current number, right? So that is where we will be using this 1 slash minus 1 for that. The third rule will be like nodes inserted after 1, 2 and 3 but before 1, 3 and 1 can be represented as 1 slash 2.5 slash 1 slash. So how you can understand it? Means 1, 2 and 3. So before 1, 2 and 3 and 1, 3, 1 there is a value which can fall with 1, I mean the second level. Just consider the second level only, right? The second level is what? 2 and here the second level is what? 3. So between these two value, which value will fall? Which is 2.5, correct? So for that reason it is like the first level will remain as is in both the cases and then the second level will represent this like the mean value. Okay, like the half of that is what considered 2.5, like that. Just an example, this is just an example I am taking, okay? But how it can be inserted is what this rule tells us. Now the fourth one is that nodes cannot have leading zeros. Means like if you have to declare this or say like assign the values, right? So in that case you will not write the values as if like 0, 1 or say like 0, 2 or something like that. So the valid values are like this: the level 1 root, then level 1, then level 2 will be 1.1, okay, and then slash is a valid value. But if you want to write the same one as like the level 1, then level 2 you want to write it like 1.01, which is not a valid value. Okay, so you need to write it like 1.1 only. So you're not allowed to use 0. Okay, so just keep that in mind. Now to prevent the errors, insert nodes by using the get descendant method. This is the very useful method that you can use before you want to create or say like insert a node when you want to insert a new node. Okay, to avoid the errors, best way is to use this method. Now how many methods are there? Let's just talk about that first. wanted to introduce it later, but then better to have it introduced before, so you will understand. Now this get root is the method, okay? Get root is the method which will return the root of the hierarchy tree. Now get root is a static method, okay? So hence need to be called as hierarchy ID, then double colon, and then get root. This is how you will be actually calling whenever you want to get the root value, means this hash, like the slash value, if you want to get from the hierarchy, then this is how you will be retrieving the root value, okay? Then the first level, or say like a particular level wherever you are currently standing, right? Means like it returns an integer that represents the depth of the current node in the tree, means at which level you are standing, right? That is in the hierarchy, at which level you are standing, that is what will be retrieved by this method get level. Now get ancestor in the parenthesis n, okay? So what is n? Means it represents the nth ancestor of the current node, where n is an integer value representing the number of levels to go up in the hierarchy. Suppose say n is 0 means the current hierarchy, n is 1 means the prior one, means like the level above to the current level, okay, means the prior value, and then one say like n equal to 2, then the level one level more to that, right? Likewise it will be going upward. This is like an ancestor method. Then the descendant method, so it represents a child node of the parent. Say like we are at a level, a particular level, and to below this level we do have one more child branch, or say like one more level we have below to this level, right? So that child node, how can we retrieve is using this method get descendant, and how we can retrieve is using the child 1 and child 2 parameters to it, okay? Now we will see how it can be implemented. Now we will just continue using the same learning DB. So we are there. Then we will create and drop and create the tables, the hierarchy table we created, okay? Now we will insert the record to this. Now I wanted to explain you this hierarchy ID, how we used or declared, right? That the node value, the data type, this is how it will be used, and this is like a not null value, means you are not going to allow the user to insert any null value, or say like you are forcing the user to put in some value from the input at the input time, okay? That is why we are using this not null keyword, okay? So rest of the column types you are familiar with, integer and varchar, all of this, right? So I'm not specifying or explaining. Now you will be inserting a record in this format, the hierarchy format, right? So how you can insert the hierarchy in the table? So whatever the hierarchy what we understood, right? So this is how you will be inputting the hierarchy while inserting a record to the table, okay? Now let us say we wanted to form an hierarchy. Say the first one is the node, then the second one is the node name, and then the third is the node type. So here, just to give you a glance of it, like what I am doing is I'm using the country as a top level, as a root, and then I'm going to the I'm using the continent as the root, and then I'm going to the country, and then the city and state, and then the city. That is how I wanted to set up, okay? Let's say like this is what I am saying, continent, say then country, then state, and city, okay? So this is how I wanted to form the hierarchy, but I am inputting the values randomly. You see, the root is inserted at this record instead of inserting in the first record, okay? I'm inputting the values in the random order, okay? That doesn't matter to it while we are inserting it into the table. It doesn't cause any issue, but while representing it only we need to sort it or something. So let's just try to do the insert of that same. Okay, so 11 rows has been inserted. Now what we need to do is we want to see how it is inserted, right? So you will understand how it is inserted. Let's see. Select star from TBL hierarchy. So hierarchy is the table from where it will return us the record. Now you see how it is inserted the records, because we have skipped the column called node level as null, because we inserted value for 3 of the columns only. We did not inserted the node level value, right? For that reason it is coming up as null, means there is no value. Okay. So the first value is saved as this value in the hierarchy ID. So it's consider, say like this is a hierarchy ID value, how it is saved in the memory. Okay. Now in the column. So now what is the node type? Node type is a state here, and say like what is the node name? Node name is the Maharashtra, is the node name that I have passed in the value. So that is what is inserted, the first value, then the second value, then the third value. That is how in whatever order I have inserted the records, it has inserted the records in. But ideally what we wanted is this record should be the first record, right? Because the root should come up the first in the order when you want to display the hierarchy. Otherwise how would you understand like which what is the root to this hierarchy and what is the label for a particular hierarchy? To do that, what we can do is we need to do the first of all, before we do that, let us just define the node labels, okay, so that we can easily sort them or say like an order them. Okay, so to do that there is a get label method. Okay, now how can it identify it? Using this value, whatever you see in this node column, that value will be passed in, means that value will give us the label to that. Now you will say like how can it return that? Means this get label method, it is meant to give you the current label for the value, whatever is the value into this column, that value or say like a label will be written and updated into this column, this node level column. We are writing an update statement to the table hierarchy, and we are setting the value for the column node level for say like first record. Consider say like what we are doing here is we are trying to insert using this value. Okay, we are trying to get the label, we are trying to get the label, what is the label of this row. Okay, we are trying to get the label of this row using the get label method, and that label whatever we get in there, that is what we are saving into this node level. Okay, that is what we are doing using this update statement, and from this table, the same table. Okay, so just for your information. Now we see that after we update how it is displayed. Okay, now you see the difference in there. Okay, okay, this is how you will be seeing without sorting the result. Okay, now how you will be seeing without the sorting and how you will be seeing with the sorting. So to do the sorting, what we will be doing is we will be using this keyword order by and then say node level. So the label which we updated here, the same column we will be using to order that records in the result set. Okay, so let us just display both this, like the first query, the select statement that we are writing here, that will just give us the node level and the current status, how it has been updated, but it will not show us the ordered records in the hierarchy format. But this is the second statement which will actually order the record in the hierarchical way. Okay, so let us just run both the statement to see that. Yeah, so see the difference between these two is here we are seeing all of them 1 to 11 records, but there is no node level, but it is not sorted, right? did not update actually. Yeah, I forgot to run this statement actually, for that reason, my bad. So we just updated this now. So after we update this and then we run this, okay, and we'll see the difference to that. All right. Yeah, so here you see the values are updated for all the 11 records, and it has given us the respective node level for that. Okay, now you understand, right? Like this 0 should be the first record in this hierarchy, so it has set up in the first hierarchy here. So continent has, it is set as the first level. Then the second level or the first level should be what? The first level should be the country after continent, right? So then it has tried to get that first value, means like the one value. It has ordered in the first value, and then go to the second, and then go to the third order. Okay, so all these levels are set: first level, then second level, and then the third level. So first level is country, second level is state, and then the third level will be city. Likewise, it has set up the order for the hierarchy, and according to that the string will display us the values within that column. Now to retrieve that node string also from the node column, how it is saved in the table is like this, but from this value you may not understand like what is the label for that, right? So to understand not the label but what actual label as a string format, right? Here it is in the integer form, but if you want to see that how it is actually at which level it is, that the node string will help us, right? How we can retrieve that is using this node value itself, node value, and then get string function for that. Okay, that is what we have used in here. You see, node dot toString. ToString function will return us the node string for that. That is what we have used here, and displaying the column value for that. Now this is about the table how we used. Okay, now adding a new country row after a root level. Now if we want to say like I want to get the root value, and say like I want to insert one more level, or say like one more country in this hierarchy, right? Right now as you see there are only two countries, right? If say like I want to insert one more country in this hierarchy, so how can I do that? That is what I am trying to explain you using the various other methods which are used for the hierarchy data type. So that you can understand how the usage of the hierarchy ID data type can be utilized. Okay, so so like a new country, say like UAE, we wanted to insert into this, right? So what we need to do is like we first of all need to find the root, right? So this is the root record where the slash is written, right? So to get this slash, or say like a node level as 0, how can we retrieve that? We can retrieve it using this hierarchy ID double colon and then get root method. That will give us the value of the hierarchy ID in this variable. Then the second record, what we are doing is we are trying to check the node type as country, where the country type where the node type is country. Get me the max node value. Get me the max node value. Max node value is what? This. In the country there are two records, right? Out of this two record, what is the max value for that? This is the minimum value and this is the maximum. So this is the maximum value of the node that will be retrieved in the result of this select statement. Let's see to it. Okay, 0, 60, right? That is what we are getting it here. So what we want to do is we want to store that value as a max country into this variable, and then we want to add one more descendant to that value. Okay, means we want to add one more subordinate to the same value at the same level, right? So in that case we want to use the get descendant value. You use the function get descendant, pass in the max value, comma null to that, and this is how you will be passing the value for that, the first node. So the variable root, this will give you the root to that. This get descendant will actually find that what will be the path after the max value of the particular level of the hierarchy. So that value it will retrieve, and that value will be saved in the node here. And then we want to set it at which level? We want to set it at the level as 1 only, right? Where do we want to save it? We want to move it at the same level where the country is, means the first node level, right? So for that reason I am putting it manually like the node level as 1, and then the value for the node name is UAE, and the node type will be country, right? All of this is what we are trying to insert, and then we will try to display them in the order by. After we do the sorting, or say like how do we sort this record, right? First of all, using this keyword order by, we will type in the column name as node level and then node. This is how we will be ordering them. Let's just first of all insert the record into this. Okay, now one record is inserted. Now we want to see to the newly added country in the right order, right? So the first record is root, then the first record is like the country India, then this Australia, and then UAE. This is the third record to that. That is what we have just inserted into this. Likewise, we can add value at any levels in between them or say after them. Okay, so this is how you will be inserting a new record to that in the hierarchy using this get root and the this get descendant method usage. All right. So now we will be moving on to the fourth type of data type, which is the JSON. Now JSON, it stores the JSON document in a native binary format. Now it internally stores the data using the UTF-8 encoding, Latin General 100 bin 2 UTF-8. That is how the say like the collation type, or say like a collation that we would be using in case of UTF-8 for that. Okay. Now if we want to declare a JSON string or say like a JSON document, how can we assign a JSON document and store it in a variable? So if you have to create a JSON document and then you want to use it or want to read it, there are multiple ways you can do it. You can store it in the variable, you can store it in the file, and then you try to read that file likewise. Okay, so here I am just trying to show you a small string we have created in the JSON format. The string is created, and that string I am saving it as nvarchar max. Okay, so we can just retrieve it from this variable as a JSON data. Okay, now just to give you idea what it is doing is, there are two records basically. If you want to say like in the tabular format, there are two records sorry, basically there are two records. One record is this, and then there is a second record, but the difference here is there is inconsistency between the kind of columns which are written from that record. Okay, so JSON is giving you the liberty to provide the required column specific values only. Okay, it's a semi-structured format data, so it doesn't have the fixed structured data, means it doesn't represent each and every row, doesn't necessarily have the same number of columns. Say like the row number 1 has five columns, and in the row number 2 you may have 3 columns, or say like 2 columns also. Okay, that is how the data would be written or retrieved in the JSON document. It gives you the liberty for that same. So in that case, let's just try to understand each of these element. Okay, now first element, how it is giving us is like the first one is the ID column, then the second is the employee first name, last name, address 1, address 2, zip code, skills. All of these are like a column. Okay, treat it as if like a column for now, just for your understanding. 1, 2, 3, 4, 5, 6 and 7 columns. Now in the seventh column again there are three different values, 1, 2 and 3. Likewise, there is a second record, but here you see the difference. The first name, last name is there, address 1 and 2 is there, zip code is there, but what is not there? Employee skills. Employee skills are missing, right? But still it can be saved. It may not throw any errors because it is meant for saving the data in this format only. Okay, so let's say like we have stored the data, we have assigned the data, okay, to this variable. We have declared this variable and we have assigned the value. Declaration and assignment together, okay, at this stage. And then we want to check here using this method is JSON. What this function does is it checks the format of this JSON string. JavaScript object notation. Actually, I forgot to write it over here for your understanding what JSON means. What I am saying here is JSON means JavaScript object notation. Okay. This is what in the short form they say it as JSON. Now so that is what you will be checking here. Like if it is a JSON, means it's a valid string in the format JSON or not, that it will retrieve in the boolean value, means it will return you the boolean value. If it is true means 1, if it is false means 0. Okay, so let us just try to see to the values alongside with the valid or invalid flag values. Okay, let's just run and see. So see, this is how it is saved in the variable, and what is the value for that is it is a valid JSON string. So the first argument or the first column JD means it's a valid value. When it is 1, it is a valid JSON string. Okay, now as we got this string into this variable, now suppose say out of this string, okay, like it's a consider say like it's a document itself with you. Okay, like in the form of variable you have got the document itself. Document of what? Document of number of records. Okay, so let's say here we are just using 2 or 3, maybe there can be number of records, and that those all will be saved in the form of a variable or saved in a string and varchar string. Now out of that string you want to retrieve only a specific number of columns. Okay, now say like last name, first name, a particular number of columns you want to retrieve. So how can you retrieve it from that is using this statement. This is the statement. This is how you will retrieve it from the this particular variable. Now how you can retrieve it? There is a open JSON statement. Okay, select star from open JSON statement. Okay, that has a built-in input parameter. We can pass the parameter to it. Instead of this, we can pass in the file, or we can say like we can pass in the variable. Here we are passing the particular variable. Now by passing this variable, what we need to do afterwards is, now say like if I want to retrieve the employee last name, it may definitely retrieve, but it may not understand that in which format I want to retrieve, say like the last name. Maybe the zip code, if I will retrieve, it will retrieve in the format of string only. Now if I want to convert that string to the integer, how will it understand? It may not understand. So I need to typecast it. Okay, so while we retrieve this string, because it's in the form of varchar, right? It means like a varchar string. So now if a string has to be converted in a particular type of content, to do that we need to define it, right? So to define it, we need to use this with statement alongside with this select statement. So select star from open JSON bracket JSON variable JSON data bracket over, then with statement, and in that we declare all this variable with their respective column names. Means say like the ID if you want to retrieve, say our ID value if you want to retrieve, what format you want to consider it from that string is 2. 2 is an integer value, right? So you are defining it as like dollar point ID. That is how you will list it. Okay, so ID is of integer type. Then employee first name is of varchar type 20 characters. Okay, then this is how you will declare it, this employee name, the first name, likewise the last name, and then the address and address too. Okay, respective the in whatever number of characters you think the string would be. Let's say like this string length is of say like 200 characters, it can be 500, it can be 400, 200, 100, whatever. But so whatever string that you as per your best estimate, you can put in that length within this varchar character. Okay, and then declare all this. Now not necessarily each and every column out of this list you may have to retrieve. You if you need only 2 column, 1 column, any respective column you want, you can retrieve. For example, I have taken all of these columns so that you understand everything, and for different type of content also, you know, like how it can be declared or used, right? For that purpose I am giving you the details. Now for the integer, the zip code, it is of integer type, right? So we will define it as integer here. Now you say like why all of these are declared, and for this we did not, so it will automatically retrieve. There is no need to retrieve that zip code value from this hierarchy, okay, or from this particular JSON string. So now this the last column is employee skills. Now employee skill is a tricky because it has like a comma separated values within them, right? CSV values are there. Now how can we retrieve that? What we need to do is we need to define it again it as JSON string. Okay, because it is declared in a bracket, right? The box bracket we have declared it or assigned it, so that we will retrieve it as a JSON or declare this data type as a JSON. Initially this column type we want to convert into the varchar max, then give the column name which is employee skills, right? The same column we will give as a column name, and then give this alias as JSON. So that entire string would be written, but it will be in the form of varchar. Okay, so this will be varchar string, it will retrieve this entire string, comma separated string, and then we do the outer apply on top of it. Okay, so what it will do is it will do the outer apply on this particular column, and again we are applying this with statement on top of it, right? You see, this is again like that how we have written it above. We again want to retrieve the same column from the JSON string, right? So how can we retrieve it? Using this with statement. Understand? This is how, because the entire JSON here we pass the JSON string, right? The same JSON string, out of that JSON string we retrieve respective columns. Likewise again we converted this employee skills in the JSON format and converted in the format of varchar max, so that again we can use it by defining a column as varchar 12 character and then retrieve it using dollar, so that it will retrieve all the employee skills. Now let us just see to it in action. Right, so first it is a valid, then second. Now both these records are retrieved. So the first value that you see, each and every columns are split with their respective column. First name, last name, address 1, address 2, right? Employee zip code, employee skills. Employee skills is still up to here. We still are seeing in the same thing. There is no difference in there. But what we wanted to see is we wanted to see it split, right? So that split is happening in this employee skill column. See, it is the same employee, but for that we wanted to split this 3 skill. For that reason we split them from the row to the column format, and we gave that column a name as employee skill, so that all of the skills with the same employee name we can see to it. Correct? That is how we can retrieve it. The second record, which is of this employee, it did not have any skill. For that reason it has kept it to the null. Right? Now you will have some of the rules to use this JSON thing. Okay, now what all rules that we follow for that? Okay, OpenJSON converts the JSON values to the types that are specified in the with clause. Means like with statement, how we converted it, right? The JSON format converts it to the respective type. Say like we wanted to convert it to integer varchar, or say like n varchar, right? All of that different types we can save it. That is what this statement says. OpenJSON can handle both flat key key value pairs and nested hierarchically organized objects. So here we saw that hierarchical value, or it can store it as like hierarchy as well. So that is the second point to remember. Third one is like you don't have to return all the fields that are contained in the JSON text. Means, as I said, right, like if you have say like 7 columns, then we don't necessarily need to return all the 7 columns. We may need we may return only first name and last name, or we may retrieve only the zip code or something. So that is possible. If you if JSON value doesn't exist, means OpenJSON returns the null values. Means, say like in this case, employee skills for the second employee, here we did not have any employee skills, right? So in that case, what it has written is null, right? That is what it is saying here. So if JSON value don't exist, OpenJSON returns the null values for that. For fifth rule is like you can optionally specify a path after the type specification to reference a nested property, or to reference a property by a different name. Means like here employee skills. Okay, now the sixth one is the optional strict prefix in the path specifies that values for the specified properties must exist in the JSON text. So all of these rules are there. You don't need to get into too much of the detail at the beginning level, but slightly as you understand this data type and the usage, you may understand it much better way how to implement and use all of these rules. Okay, so yeah, so let us just move on to the vector data types. Now this is the new type, which is vector. Here there is a limitation. First thing, when I'm saying the vector is like mainly designed to store the vector data optimized for operations such as similarity search and machine learning application. For these two purposes mainly, this vector data type is going to be used. It is stored in an optimized binary format, but are exposed as a JSON arrays for the convenience sake. Okay, it is saved in the binary format in the database, but when you retrieve it or when you see it, it has to be retrieved as if like a JSON array. How we just understood JSON data type, right? Each element of the vector is stored as a single precision floating point value, means 4-byte value. Now syntax of the column name, syntax of the vector, how we can define that data type. The column name, then the vector data type, in the bracket we will be passing in the dimensions, whether it is not null column or say like a null column, and the dimensions, how we can pass in maybe 1, 2 or 3 number of maximum dimensions supported is 1998. Okay, remember that points to remember is like the data type is in a preview mode currently in the SQL Server, and it is a subject to change. Very important thing to remember. This vector data type may possibly not work in this SSMS currently. If we try, I'll show you the example now, but this doesn't work in the SSMS. It has to be worked in the Azure cloud only. Okay, so but for the understanding purpose, I am explaining it here how it can be used basically. Okay, how it can be declared, how it can be leveraged. Okay, that is what I am explaining here. Then second rule is like the information schema in the columns reports the column using the vector type as a var binary. Instead of vector, it is showing you the data type as var binary. Now you want to know what is information schema dot columns. Then let me just show you one example quickly. Now, what it has written me. What is information schema dot columns? Information schema dot columns is returning me the number of columns, number of tables under this database called learning DB. So for each of this database, whatever you see in this list, right, you may have to go select this each of the respective database, and then say like for adventure works 2019, right, if I select it and if I run the same select statement, what I may see is all of the tables under this database along with its column and along with its table specification, right, the data type and all of that, like the variable length and nullable, not nullable, character set and everything, all kind of details, the collation details, everything it retrieves. Whatever is saved in the table, that is what the table description basically you can say. So that is what is written using this select statement. So just say this. So what it is saying here is like for the database data type, instead of say vector, here what we are seeing integer, right, likewise it has to show the vector, but instead of vector you may see as var binary. You may see it as var binary is what they are saying in this second rule. Okay, and workaround to get the correct data type is to use the sys.columns system view. The same similar identical way to display the same content is sys.column. Okay, now the result can be displayed with sys.column. Okay, now the same but the different format only. Okay, it has a little bit different format than what you saw in this information schema. See, information schema can be used open wide with any of the relational databases. It has the same construct, but this is specific to only SQL Server. Okay, just keep it in mind that sys.columns table or the view is basically this view is specific to the SQL Server only, whereas information schema is a kind of a view that is being used, or it can be similar to the other databases as well, other than the SQL Server, the relational database. Okay, so yeah, so that's what I wanted to say here. So, and the third point here it was saying is sys.column returns the length of a vector in the bytes. So here say like the vector in the length column, right? Where do you see the length column here? Sorry, sys.columns has the length column, right? Max length column, right? Here you see the length of that. Okay, and any other column specific to that? No, that's the only one, right? So what it does is here whatever you see, it is the length of the length of vector in the byte format. So suppose say if you see instead of using this information schema dot columns, you may need to use sys dot columns to see the vector as a data type. But now instead of var binary to vector, you saw the correct data type, but you still need to see the bytes in the correct format, right? To see to that what is the exact length of that, right? Bytes may not give you or tell you like how many characters are going to be saved. To get that, or say like how many dimensions to be saved, to know that, to get the number of dimensions, use the following formula for that. Means the length column means max length column, whatever is the value in this, that value you will put in here minus 8 as a bit. Okay, for each, consider say like length, say like for each byte, say like here max length was 1 as a max length. Okay, now 1 minus 8, which will be minus 7, but say like if there is like a 4, so then minus 4 will be the value, and then divide by 4, which will be minus 1, that will be the dimension. Okay, now here whatever we are saying, like say length is like a 20 is what the length mentioned here. Okay, for that, now 20 minus 8 is what they are considering as 8 is what they are just removing, subtracting from that main length. Okay, and then dividing it by the 4, because the length is considered in the 4 byte, right, floating point by value. For that reason, single precision value, for that reason we are dividing it by 4. So that value like 12 divided by 4, which will be 3. So 3 dimension will be saved for a particular value. Okay, that is how it will be used. Now implementation of it I did not use for now, but just for the limitation and for the known issues, you may just refer to the Microsoft documentation for now. I'm just taking you to that. Okay, I think, yeah, here it is open. Okay, so here it is displaying you the vector data type and its usage. So you can go through this documentation. I'll give you this link to the vector data type, like the link of Microsoft documentation in the video, so that you can refer to the documentation in detail, very great detail. It has given the content and the database and the limitation basically, right? So what all are the limitation to it, right? All of that is given over here with the defined, the known issues also it has mentioned, right? Like in tools like SSMS, Azure Studio, or MS SQL extension for VS Code currently might not be able to generate the script of the table that has a column using the vector data type. So it doesn't support currently. Okay, for that reason I am not able to explain you the running this thing basically. So let me just take you back to the SQL window. Okay, now how you will define it, how you will assign the values, that I will tell you for understanding. So using this learning DB, we will go to learning DB, then we will declare this variable data type as this variable vector, and then data type will be declared as vector keyword, and then in the parenthesis you will be passing in the dimension as in the syntax. Okay, as per the syntax. So say like when I'm mentioning like 5 dimension, means like the 5 separated values, 1 comma another second value, then the third value, then the fourth dimension value, then the fifth dimension value. All different dimension values you will pass in the box bracket and then close it. That is how you will assign a value in the kind of variable and then try to see to that value. Here you may see the errors actually. Okay? It doesn't work. Okay, so likewise, how you want to use or how you can use it in the case of declaring with the table is, in the table the column we will declare the column name, and then the column type will be like the same way how we declared it here, and then null or not null type, and then we insert the values like respectively 5 dimensions, we will insert the dimension values into that, and then we'll try to see to the values. Like that we will run them. That's it, I think, for this vector data type that I need to share. I'll be putting in the link to the videos references so that you can use it for the reference. Okay. That's it for the day, and thank you. Happy learning.